What are the domain and range of all 6 of the trig functions? Let's start with sine. Sine is this blue graph here. The domain is the set of all possible x values in the function, and the range is the set of all possible y values. So when we look at the domain, we see that all of these different angles are possible, and each of these cycles represents going around the unit circle one time. And we could keep going around the unit circle an infinite number of times and increase the number of angles in both directions. So this is a continuous function. Every value of x is represented. So we say the domain is all real numbers. Now the range only goes from -1 to 1, so we say the range is from -1 is less than or equal to y is less than or equal to 1. Now in this class this year we're going to be using what's called interval notation. And so to show you what interval notation is for all real numbers, we say x is an element of the set from -infinity to infinity. And notice -infinity and infinity are enclosed in parentheses. For -1 is less than or equal to y is less than or equal to 1, we say y is an element of -1 to 1. But notice they are enclosed in square brackets. If we say less than or equal to or greater than or equal to, we'll use square brackets. If we just say less than or greater than, we use curved brackets or parentheses. Because infinity is not a defined end point, but is kind of an open end point, we use curved brackets or parentheses for infinity. Now let's look at cosecant. Cosecant is the red graph here. Cosecant has a little more complicated domain and range. The domain is all of the real numbers except any place where there's an asymptote, because we cannot use those values of x. They're not included in the domain because it's impossible for there to be a y value for those x values. So notice we say x is equal to all real numbers except for these multiples of pi, 0, pi, 2 pi, negative 2 pi. Now what's a more concise way of saying except all of these multiples of pi? We can say x is an element of -infinity to infinity, which is all real numbers, x not equal to pi n. So that is all the multiples of pi, because n in math represents an integer, a positive or negative real number. Actually, n often represents only the positive ones, but in this case we're using it to represent both positive and negative real numbers. Now what's the range? The range is that y is less than or equal to -1 or greater than or equal to +1. Once again, we could write that in interval notation by saying y is an element of the interval from -infinity to -1, or, that's it, or, it means a union sign, or the interval from 1 to +infinity. So when we have a less than or a greater than symbol, one of our interval ends will be infinity or -infinity. Now let's look at the domain and range of cosine and secant. Cosine is going to have exactly the same domain and range as sine does. Domain, all real numbers, -infinity to +infinity. Range, -1 to 1, including the endpoints. Secant has the same range as cosecant, either -infinity to -1 or +1 to infinity, but the asymptotes are located at a different spot. Instead of multiples of pi, they are pi over 2, 3 pi over 2, -pi over 2, and -3 pi over 2. Now we can't just say those are multiples of pi over 2, because pi is a multiple of pi over 2. That's 2 pi over 2. And so what we have to do is realize that these intervals are still pi units apart, but we just started at a different place. We're not starting at 0. So we say x is an element of -infinity to infinity, all real numbers, with this exception. X is not equal to pi over 2 plus pi n. In other words, starting at pi over 2, anytime we add or subtract multiples of pi, we're going to hit another asymptote. Now let's look at tangent. Tangent has a range, unlike the other ones, of every possible y value. Notice we have an arrow going down, an arrow going up, and it's a completely continuous graph in the y direction. So we say our range is from negative infinity to infinity. Y is an element of negative infinity to infinity. X, however, has asymptotes, and notice the asymptotes are exactly in the same places they were for secant. So it has the same domain as secant does. X is an element of negative infinity to infinity, and x is not equal to pi over 2 plus pi n. And then last but not least, we're going to go to cotangent. So we see that cotangent also has a range of negative infinity to infinity, just like tangent, but its asymptotes are at multiples of pi, so it has the same domain as cosecant does. X is an element of negative infinity to infinity. X is not equal to pi n. So those are all the domains and ranges, or as Dixie would say, the domains and the ranges of our trig functions. Thank you very much.